our example for our greps. Okay? So the command we're going to run, we're going to pass the dash dash color option to grep. This is useful when you're doing some of these tests because, remember, grep shows you the line, shows you the entire line, but it colorizes the part that your regular expression matches. So this is really good for testing your regexes. So if we do something like this, grep for A in the file called words, remember, grep gives you lines. Grep gives you lines. What we've asked here, the English version of this would be, show me every line in the file words that has an A in it. Anywhere in the line. Beginning and doesn't matter. And there's a lot of them.
Well, it's a good thing you're on a dialogue.
If only I had a note of that. Okay, I'm going to kill that because there's a ton of them. Okay, and notice it colorized. Even ones that match, I got two A's here. Okay? Pretty simple. Character-based. Character-based. A, B, and C. Okay? Well, let's do an example. Let's do a test here. So if my file words look like this, that's a 1. Which lines would that match? All of them I hear. Anybody else?
Last two.
Sam says the last two.
I think the last two.
Craig says the last two.
Oh,
Regular expressions are built up character by character, but they're treated as a whole. So this is searching for ABC in the file words. So yes, the answer is these last two. Not these two. Represent. Okay? We're going to, I want to leave this up here. I'm going to run out of board space, but regular expressions are broken down into different categories. The first one is characters. We've seen the first example. A character matches itself, right? A equals A. That doesn't get much more simple than that, right? Okay, there are also I'll make sure I do this right so I don't confuse the heck out of myself. Okay, there are some special characters. Some of these are non-printing characters. Like, for example, \T represents a tab. Okay, I can't write out tab, right? Okay, the one special character that we really care about here is the dot. What does dot mean in regular expression land? Well, first, what does dot mean in file globbing land? What did it mean over here?
Nothing.
It meant a dot.
The dot.
Matched itself, right? Not special. It's special in regex land. What does it mean? Sam?
Any character.
Any single character. Any single character.
So it's kind of like the question mark.
It's sort of like the question mark in file globbing. Be careful the parallels you draw between these two because you'll confuse yourself. Because we haven't got to question marks in regular expressions yet. Okay, let's go back here to our simple example. Thank you, Aaron.
Oh, you rock. Somebody get her a picture.
If this is our new grep line, which of these lines will it match?
Now it's all.
Now it's all of them.
Yes.
Any character, and then a B, and then a C. So 1BC, you bet. 2BC, you bet. ABC, you bet. ABC, you bet. Okay? Characters, single characters. Now, notice that it didn't make any difference where these guys were in this line, right? Our expression just said, so it's basically what we're doing when it amounts to a substring match, anywhere in this line. If we care about where this stuff goes, then we start talking about anchors.
Away.
We've already seen this already. Yeah,
I'm going to interrupt you.
Please do.
This thing on your cheat sheet that you had up is actually important about the dot. Here it is. Matches any character other than the new one.
okay. That's true. That's worth making the distinction of. Any character other than new line. 99% of the regex tools we use are line-based, so they handle that for you, right? But you're right. It will not. The new line is the character that's not matched. New lines are always treated sort of special in this situation.
It's a weird gap here.
Yeah. The thing to remember on this, and we're going to get down to this, you're going to go, my God, they couldn't have made that more confusing if they hated us from the get-go, right? But you got to remember, this is what we're dealing with. These are the only keys we have available. The people that created computers in their infinite wisdom didn't know about Unicode way back in the day. So we're stuck with ASCII. So we're limited to what keys we have in the keyboard. There aren't that many of them. And you get something as powerful as regular expressions, you're limited to how you can express the logic you want to express with this limited set. So we have to reuse things. So we have to use a dot in a way you wouldn't normally think of as a dot. And there are even some things, we're going to get one example inside a regular expression where the same character means two totally different things depending upon where it is in your regular expression. That's just the way it is. Because we don't have a giant keyboard that has 1,000 keys on it, right? It'd be awesome if we did. Well, I don't know about awesome. So you're going to see a lot of things you think it means this, but it really doesn't, right? Oh, you're going to be cameraman for me? Thanks. There are quite a few different anchors you can use. That cheat sheet I had up there, which I'll send you a link to afterwards, I think defined 8 of them. I only ever use 2. And for the interest of not really confusing everybody, we're going to stick with 2. Caret means start of the line.
Right.
$, end of the line. So, continuing with our example here, if I did that, which line would that regular expression match?
The
Would it
first
match
3.
this one?
Yep.
Yes.
Nope. Nope. Yeah, it would.
Yeah, it would.
Nope. Yeah, it would.
Oh, no, because
Dissenting
there's-
opinions.
Beginning of the line. Okay, yeah.
Beginning of the
Yeah.
line.
Beginning of the line, but
Yeah.
So,
one would be lined up with B, so that would not match.
Right.
okay, so we say no here.
Right.
How about this one?
Nope.
No? How about this one?
yes.
Yes? How about this one? No. That's correct. So in this case, only this guy would match, right? Start of the line, any character, and then a BC. This is start of the line, any character, and then a B. Nope. Start of the line, any character, and then a B. Nope. Start of the line, any character, and then a BC. Yes. Start of the line, any character, and then any character, and then a B. No. So you're right. It would just be this one. End of the line. Get rid of that and put a $sign at the end of him. What'll match?
1, 2, and 4.
1, 2, and 4. That's right. Anything and then BC and then the end of the line. Not this guy because it ends in 4. Check it out. You now have an awesome crossword puzzle solver. Using this words file. Give me a word that starts with B. Well, give me a 7-letter word that starts with B and ends in D. How do I write it? Knowing what we know here, how do I write a regular expression that would represent that English phrase? Give me a word, a 7-letter word, starts with B and ends in D.
B dot 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 B.
Rep. B, 1, 2, 3, 4, 5, 6, 7. We got to anchor it, right? If we didn't anchor it, we'd get more than what we wanted, right?
Right.
Because you could get maybe a 9-letter word that happened to have a D in the 7th spot if we didn't have the end anchor on it. Or you could get a 9-letter word that happened to have B in the 3rd spot and D here if we didn't have the front end anchor on it. That's called your being too greedy. You don't want your regular expression to be too greedy. And that's one of the things that can trip you up in doing this, because you can be in situations where your search is too greedy and you're still getting the data you want. You're just getting extra. And sometimes that's okay. But then you're going to have that one test situation where it's not okay. And everything's going to break. And you're going to wonder, why has it worked forever? Why is it not working? Because you had that one test situation that broke. So let's prove this. Let's say grep anchor B 1, 2, 3, 4, 5 D anchor. Watch, it's going to be nothing. Oh, there we go.
127.
So here is all the words. Now some of these, not exactly Scrabble-worthy words, right? But burgled, bursy, bursted. Okay?
Busload.
Pretty handy.
Buster.
All right, pretty simple, right? Any character. B matched itself. Anchors here. Now, you notice the difference between what I typed and what I wrote here. I typed this. I put double quotes around this. It's not necessary to do that, but I've gotten bit enough times by Bash's interpretation of some of these special characters. I just stopped even trying to remember which ones Bash hates and which ones it's okay with. So I just put everything in double quotes. That way there's no problem. It's completely unnecessary in this case, but you know what? I don't care. So I'm going to keep doing it. Okay, there's more anchors. There's like word anchors and there's other stuff. Don't care. I only ever use these 2. Okay. We have characters. We have anchors. The next category, character classes. here's where we start getting into a little more advanced. Okay, a character class is defined by a bracket. Remember, regular expressions are built up character by character. This is one character. It means A or B or C. You can also do ranges. Any lowercase letter. Case sensitive, right? Any lowercase letter. However, this is also valid. You can combine the ranges together inside one character class. It doesn't just have to be letters. How about this? A, B, C, 1, 2, 3, and a colon, and a semicolon. Match any of those at that one character spot. This isn't, this isn't searching for a 1, 2, 3, 4, 5, 6, 7 letter string. This is searching one character. If I just say grep this in words file, it'll give me any line that has an A or a B or a C or a 1 or a 2 or a 3 or a semicolon.
Those aren't actual classes.
Sure they are.
They're really ranges.
Inside the class.
Well, that's not a range. ABC isn't a range.
You know my cheat sheet, what your cheat sheet, I'm look at it.
Well, cheat sheet's clearly wrong. All right, fine. I know what you're saying. I lump this all together. The next thing is the actual character class, right?
Well, I know where you're going with that, but
Well, let's get through this then, and we'll. Because you're right. There.
the only reason being different about it is because if you ever end up, and I don't know if anyone will end up sometime maybe do this, you end up having to figure out enhanced regular expressions versus the old style regular expressions.
Yeah. Extended regular expressions.
Yeah, it could mess you up.
You're right, because that's where the break is, right? From now on, it's extended. Okay. I don't say that specifically because I hate these with a passion. I'll show you why in a second. These, it's because of the syntax. Okay. There's ways to represent these ranges that we're talking about here. There's also shortcut ways that the regular expression library gives you, which saves you a heck of a lot of typing in some situations. One of these is this guy. The syntax here is bracket, colon, and then a keyword. In this case, the keyword is alpha. Any alphabetic character. It's the same thing as this. Now, honestly, you're not really saving a whole lot of characters here. In fact, 1, 2, 3, 4, 5, 6. You're actually typing more here. Maybe this is more readable to you. Okay, whatever. Here's why I hate these. Some of these are useful. Like there's one called punct, P-U-N-C-T, punctuation.
Oh.
Match any punctuation. That's useful. I don't want to remember what all the different punctuation I got to type in, right? That's useful. Okay? Know what I hate about it? The syntax. These ranges are defined inside of brackets. A range is defined as being inside a left and a right bracket. This is a character class, which goes inside one of these ranges. This character class also happens to have brackets in it. So you know how you write this? Because, and George is right, this is officially the character class. This defines it as a range. Because you can do, this makes a little more sense if you think of it like this. It's perfectly acceptable. This is a perfectly acceptable regular expression.
Okay.
Any alpha numeric character, or a 1, or a 2, or a 3. This makes a little more sense if you look at it this way. But when you write it this way, this strains my brain for whatever reason. It's honestly, I avoid these like the plague for this reason. Because 9 times out of 10, I will do this. And wonder why it doesn't work. Because what is this? This is a range, so it's colon or A or L or P or H or A or another colon. Because I'm missing that. I have taught this I don't know how many times. I have this one shell script. We're not going to have time to break it out tonight because it's a monster. It's like the biggest regular expression I ever wrote. And I've taught against this for like 8 years. I was teaching it last week. I found an error in it. You know what the error was? That.
Deep breaths, Adam.
Drives me crazy.
Deep breaths.
Drives me crazy. And I understand, it makes sense. But it's just that syntax, the way it lines up, it's just like, God, come on. George.
I'm not going to say you bet your mind on regular expression. That's regular expression I ever seen.
Yeah.
Was a wiki implemented with a parser with one regular expression.
Yikes. I'm not that masochistic.
I did not see that. I looked at that. I was like, what the?
Okay, remember we're building on these, right? We're building on what we know. So if I do this, I'm going to go back to my 1, 2, 3 example here. We can do anchors here, right? So show me any line. The English equivalent of this would be, show me any line that has, what, this is only 4 characters here, right? Any alpha character, and then a 1. No. No.
No.
No,
Damn it.
It's
This
one.
is 1 character, see?
Could be
This is
any
1
alpha.
character,
Alpha or
because it's
alpha.
defined like, it's defined by this. Inside, this is 1 character. If any alpha, or a 1, or a 2, or a 3. So if I ran this against my words file, anchored at the beginning and the end, how long are the lines I'm going to get? Going to be 1. 1, right? Now, okay, George did make a good point here. There are, the regular expression library is split into 2 parts. And there is the normal, am I confusing everybody yet?
I'm
Oh.
watching the cameraman.
There's the normal regular expression library, and there's the extended regular expression library. We have defined so far, up to here, what is defined as the normal regular expression library, everything above here. Well, you just call grep by itself, you call set all by itself. This is the logic it pulls in to do this. As soon as we get down into this territory, and the stuff and the categories I'm going to talk about next, we're into extended regular expression land. You have to specifically tell the tools that you're using that you need to call this logic into play. With our grep command, you have 2 options. You can either pass the -E option to grep for extended regular expression, or my favorite,
Greppy.
egrep. Greppy would have been funnier. Egrep. Don't confuse yourself with this. From now on, from this point in your lives forward, just always use egrep. Or alias it or something. You'll save, there's no reason not to. You'll save yourself a lot of headache. Because you'll have a perfectly valid regular expression, and you'll wonder why the damn thing doesn't work, and you'll troubleshoot it for 3 hours before you realize, oh crap, I'm calling grep instead of egrep, and I threw some weird character class. All right, so in order to test this, I'm going to have to do egrep. So I'm going to say egrep. We all see that? Anchor. Range. Couldn't think of the word. Start of a character class, colon, alpha, colon, end the character class. 1, 2, 3. And the range, anchor, in words.
So how many are there going to be before you do it? How many entries are you going to get?
Oh, I don't know. This file is exactly a dictionary file.
Exactly what you're going to get.
None?
No,
Oh.
52.
Oh.
No.
Nope.
Just
No,
large.
you're wrong. Because look at the top one.
Yeah.
I don't know why, but it's a 2.
And you have capital and lowercase.
That's why he said 52. He thought it would just be the alphabet.
Well, no, because I did WC-L on mine. I got 52.
What OS?
This is Linux, or this is Debian 6.
Maybe your Debian words file doesn't have a line that just has the number 2 in it. My CentOS one does.
Maybe Debian doesn't use numbers.
Debian's a binary, so it only goes to 1, 0 and 1. There's no 2. You're right, George. It should have just been, this words file is exactly a dictionary file. Okay. I don't
I
know.
was going to say,
Cycle probably has like 6 characters. It makes sense only exists when it started.
Yeah, it's not a, yeah, you're right. It's not a dictionary file. It has like Afghanistan is one of the words in there. I mean, it's not like a, yeah. It's not a word. It's a, okay. You get it. Okay, one more thing to talk about here. The logic inside these character classes. You can have ranges. You can just have lists like we saw here. All right, here's one more. If you weren't confused enough already, inside the character class logic inside of here is a little bit different than the regex logic. So inside a character class, you can have negation. So you can say, don't show me, ABC. Show me everything other than ABC. Now, if you're a programmer, you know that normally the negation signal is the exclamation point, right? That'd make perfect sense if that were the case here, because the exclamation point isn't used anywhere else in the regular expressions. But it's not. You know what it is?
Dash I.
It's the caret. It's a symbol we've already used and defined a different way. But inside this class, it means something different. I don't make the rules. I just complain about them. So this...
That goes on the t-shirt, dude.
I don't make the rules, I just complain about them.
This is a valid regular expression. It is a range. Give me a
dash I
line.
goes with grep to inverse the response, doesn't it?
Well, if it's inside a bracket. No, you're thinking of the dash V option to grep. That inverts the
that's a
response.
V
Yep.
for inverse.
You can, yeah, grep can still do it. This, just inside this set, show me every line that does not have a lowercase letter on it, is what this is saying. If I just grep this by itself. Now, I could anchor it, I could do whatever, but just this by itself, every line that does not. See, here's where it breaks your brain, though, is when you do this.
Oh, that just means it's a renamed line.
Yep, two carets in the same regular expression, two completely different meanings, all dependent upon where they are in the regex. Yeah. It's always the exceptions that get you, right? It's that weird little stuff like that. I don't think in my life I've ever typed that. But yeah, you gotta understand what that means. So if you ever see it, it'll make sense. Okay, we've only got two categories left. We got characters so far, we got anchors, we got character. All right, we'll call these ranges then. Make George happy, because he's right. Damn him. And now we have quantifiers. What we've seen so far is just matching one and only one character. We put some together, right? This is 1, 2, 3, that's fine. But sometimes we may want to match more than one. So we have a quantifier. Here's where our asterisk comes back into play. And the problem with this is you're going to get a regex that looks like you think you know what it means because you've done file globbing since you were 6. Yeah. And it doesn't mean what you think it means. Quantifiers are not regular expressions by themselves. In the file globbing world, that is a perfectly valid file glob, right? ls space star works. That is not a regular expression. That is a quantifier, or you can call it a modifier, but quantifier really means it's modifying it by counting. Okay? This modifies an existing regular expression, or quantifies it. It says, how many of them do I want? 0 or more. And this is written like this. That is a valid regular expression. It means, if I just did grep a star in words, show me every line that has 0 or more instances of A. So how many of the lines in words am I going to get from this guy? All of them. Because they all have 0 or more instances of A. The ones that don't happen to have A have exactly 0 instances of A. So I'm perfectly happy with that. You look at this in file glob and you think this would give me every word that starts with A. Nope. If you can get past this, if you can untrain your brain to see this as a regular expression, then you'll be fine. That's the hardest thing. I've done this for how long? I still make this error. In my Apache configs, I will still throw a star at the end of a regex line thinking it means anything past that. And it's not. It's modifying the thing to its immediate left, saying 0 or more instances of that. Yeah, that's exactly right. And the kicker on this is sometimes it'll appear to work. And that's what really kills you.
Yeah.
Is sometimes it'll work. But you'll get what you think are the right results, but it's different logic behind it.
Show us an example. If you would, please, just a short one.
Sure.
Because I'm not understanding 100%.
Okay. Let's go back to our little test here. How many lines will that match?
1.
You know what? You're right. I should have anchored it. Let me anchor it. Okay, now do it.
Yeah.
It'll match the first 3.
Okay, explain the logic for me. 'Cause
Okay.
I'm not following this one.
That's fine. Remember, you have to read regular expressions from left to right, character by character. So, anchor, right?
Start. Yep.
A matches A. 2 matches 2. However, 2 has been quantified by the existence of the star here. Quantifiers always quantify the regex immediately to their left. Not A2, not the whole thing, just the regex immediately to their left, which in this case is 2. And star means 0 or more. So the English version of this regex would be, show me all the lines that start with A and then have 0 or more instances of the number 2. Starts with A, has 0 or more instances of 2 right after it. Starts with A, has 0 or more instances of 2. So yes. Starts with A, 0 or more instances of 2, doesn't start with A.
But you would have the exact same result if you didn't put the 2 star after.
Right.
True?
In this instance. It doesn't, it's not gaining you anything in this example.
How many will that match?
One.
Just the first one. A, then 0 or more instances of 2, in this case, 0, and then a 1. A, 0 or more instances of 2, but then no 1, no 1, more.
Okay.
0 or more. See, you think the file glob, you'll think this will match. You know. You think all these will match, right? Because the star matches anything, right? If this was file globbing, it would. But you also got to remember, and see that's the killer, is your file globbing logic says, oh, I know how this works. And you have a file like this, and it works. And you think your file globbing logic was applied. It wasn't. Because in this case, the regex logic is the same as the file glob with these 2 examples. But then look at this example. Would that one match? You know what? I wrote that wrong. No, it wouldn't. So. Would that match? Yep. But not with your file glob logic.
No, you're right.
That's what'll kill you. You'll write a regex and you'll accidentally throw file glob logic in there, and you'll think it'll work. It doesn't. It's not working. It's not following your logic. The end result may have been the same. And then this will happen, and you'll go, oh my God, why did this all of a sudden break? More quantifiers. The plus sign. Zero or 1. No, God. Sorry. I mixed them up. Question mark. I always mix those 2 up. 1 or more. Okay, the question mark. 0 or 1 times. So back here, you thought you knew what question mark meant? Doesn't mean the same thing. Question mark means 0 or 1 times. Remember, these are not regular expressions by themselves. They quantify the regular expression immediately to their left. They are not standalone. You always have to look at that quantifier and look immediately to the left. What am I changing? Star, what am I changing? You know, make this guy a plus. 1 or more instances of 2. So A, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 1 would match. A, okay, in this case, back to here, which of these 3 lines would match this guy? That's a 1. My terrible scribble. The first 2. Why not that guy?
The L's wouldn't cancel.
The L's?
Yeah.
No.
1 or more.
2s.
And then the number 1.
Then
You
number
got 2
1.
L's in there.
1 or more. I'm sorry. You're right.
If it was
You're right. I'm
2,
sorry.
1, yeah,
You're
I
right.
can see where that would work.
You passed the test. Good job.
Yeah.
The point I was making was this guy. This guy won't match. When I had the star there, it would match. He won't match now because this is 1 or more instances of 2. Yeah, I should have done this, right? 2, 2.
Yeah, there you go.
Then we match. Okay, 1 or more. Okay, a few more quantifiers. There's only 3 more. Here we have a new character we haven't seen yet, a brace. Match exactly n times. N, comma, match, M-A-T-C-H, n or more, and then finally, n, comma, m, match between n or m inclusive. English version of this, show me every line that starts with A and then has exactly 3 twos. And then anything else, right? Because I'm not anchoring here. If I anchored it here, it'd be, and then end of line. But I'm not. Go up here. Give me the English equivalent of this guy.
Can you,
Three alpha
Three
characters.
or more alphanumeric or alphabetic characters.
Right. Show me every line that starts with 3 or more alpha characters, uppercase or lowercase, and then anything else. Okay. If I just want, yeah, I could have put a dollar sign in. I want to see all the 3-letter words in this words file. No numbers, no punctuation, none of that crap. Every line that starts with any letter, exactly 3 of them, and then ends. Show me all the 3-letter words. Yeah, because otherwise I'd get 4-letter words, 5-letter words, 6-letter words, 10-letter words, right? Sure I would. And then what else though? I'm not quantifying the rest of the line. I'm not saying end of line. Grep says show me every line that contains
Is
this.
that, okay, now wait.
Watch.
It would be
Okay,
every word with
All right,
three
you're right,
alpha
and I'll say, and, okay, something I was about to ask you, because
Yeah.
I was going to point it out, it's one of those complicated, annoying topics that I'm sure you didn't want to talk about.
Okay.
Greedy versus ungreedy.
Yeah, I
told you.
don't think we have enough time to get into that, honestly.
you're seeming a little greedy on this one.
Yeah, I did not anchor this guy on the end. So I did the color thing, so see what's matching. So ASEL matched because you see the AS in ear red and this guy's black. This guy matched ASE and LAR because it's 6 letters. So I have to throw the end anchor on there because grep gives me lines.
So
There. If I
just
throw the
three-
end anchor on there, it's just 3 letters.
That's interesting. If you go to the previous one, though, it evaluates 3. Then
and another 3.
it evaluates another as opposed to evaluating 3 from the first
Yeah, I think that's a
character,
weird
3
thing with
from
the
second
color, because
character.
you wouldn't think it would do that because the anchor, you're right?
Yeah.
Maybe that's a glitch in the color option of grep, I don't know. Because obviously it still matches because I had that first 3. So it really shouldn't colorize that second 3 because they don't
Okay,
match the
it's matching
regex.
a 3 and then a 3 as opposed to a 3 from the first character and a 3
Oh,
from the
yes.
second character.
Yes, groups
and
of 3.
from the third character.
That's right, groups of 3.
Because 8-letter words were 3 red characters, 2
And then two black characters.
at the end.
You got it.
Watching that go on.
You got it. You got it. Okay, there's only one category left, but it's broken down into 3 different sections. You know, it couldn't be that easy, right? I'm running out of board space. Okay. This next one
Get
is
rid of the
called
blob stuff over here on the left. I think we've learned not to trust
Yeah.
that anymore.
Don't Trust the File Blob.
We're globless now.
No blobbing. No blobbing.
Something in our script.
I'll do it over here, okay. Finally, atoms.
Of course.
ATOMS. Atoms are indicated by parentheses. There are 3 uses for parentheses. Creating an atom by itself or grouping. So, back to our, well, we'll just make it an example. So we'll say, now when we did this before, what does this mean? There's no space here, I drew that way too far apart. What's the English equivalent of that?
Show me.
A plus 3 Bs.
A plus exactly 3 B's, right? What if I do this?
A or B.
Yeah.
Nope,
Now
no
it's
or.
parentheses, it's A, B, A, B, A.
That's right. This is now treated as a single character. This is grouping. I've created, this is called an atom, ATOM. I've created an atom out of this. So I can treat it as a single regular expression. Therefore, my quantifiers act on it as a whole instead of the individual ones. So this would match AB, AB, AB.
So if you were looking for the word cab and it had cabby, you could put CAB and it's going to show you cab plus cabby plus cabits or right?
Oh, if I had CAB in here.
Yeah, if you put
Yes.
CAB in there, it's going to
Well,
show.
no, because if I still have the
It's
3
gonna
there.
show you cab,
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 cab, cab.
CAB. Yeah. With all
Thank
the,
you,
with all the
thank
match.
you.
Okay. So, one use of atoms is grouping. The second use, what George said, was called alteration, which is indicated by another one of our favorite keys, which we use in shell scripting all over the place, but has a different meaning here. The pipe. A or B. Now you say, wait a minute. Why don't I just do that?
Yeah,
That's A or B.
yeah,
You're right, these two are equivalent.
okay.
What about this then? Cat or dog? Can't do that with us. I gotta group it. Cat or dog. 2 or more instances
Is
of
there a
cat
character
or dog.
range for domestic pets?
Now, what's the definition of it?
B-I-T-C-H. 2 or that was a good one. 2 or more instances of cat or dog, anchored at the beginning of the line. I mean, you start connecting all these together, right? You start growing this. You can see how it can become pretty complex. You look at this. I mean, think about this weird syntax where you came in tonight. You've been, oh my god, what does that mean? Right? We just break it down. It's an anchor. This is an atom with alteration saying this or, and this quantifies the regular expression immediately to its left, which I know is here because I've defined it with the atom.
So it's looking for anything that says cat, cat, or dog, dog.
At the beginning of the line.
Or
cat dog.
Or dog cat.
Or dog cat.
But it
This
says
is
2
or.
or more.
Yes. So
Of whatever's in.
this
inside
isn't,
that
or
one.
whatever's in here, and this is an or.
Oh, that's.
Admittedly,
All right.
admittedly, a very contrived example you probably wouldn't run across in the real
Well,
world.
no,
still.
but it makes. Then now, like I said,
I'll show you some real world examples here that'll bring this together a little bit more. I think. Okay. Now the last one, and now okay, I'm going to say the last one. There is more. I'm not covering every ounce of regular expression. If you look at that cheat sheet, I'll show up here in a minute. There's more stuff that honestly I don't understand. We talk about like forward look aheads and this stuff. I don't even know what that means. Yeah. Okay. So the last bit that I know, which is really for the most complicated as well, is back references. When you create an atom, which is anything inside the parentheses, you can reference later on the value of whatever was inside that atom by an incremental variable name. The name of that variable, just because the universe hates us, depends upon the application you're using. You usually use this with sed. Okay? So you can say, what's my really contrived sed example? They have one in the curriculum. I hate it, so I'm not going to use it. We haven't done any, we'll be using grep, but sed, sed the stream editor, read a file, we'll modify the line in memory and then spit it out to standard out, applying the regular expression library. If you want to use the extended regular expression library, what do you call it? ESED, right? That'd make way too much sense. So you pass the -E option, right? Like grep? Yeah? No. R. R. Because we didn't have enough stuff to remember. Let's use something totally different for set. So
that's
it's
just
R.
recursive Z, right?
It just annoys me is what it does.
That's R for remember.
It's good. I'm going to totally remember that. The syntax for sed, there's a million syntax for sed, but the basic is search for this and replace it with this. And you can search for a regular expression. So the simplest set is this: search for A, replace with B globally. The S stands for search, the G stands for replace every occurrence, search for A, replace it with B. All right, a more complicated example would be something like search for, A, B, star, what edit one of our regexes and replace it with something else. Okay, if we do an atom here, if we say cat or dog, plus one or more instances of cat or dog, then you can do fun stuff like this.
Replace it with snake.
I was trying to be a little more complex, but yeah, you could. I'll do something like this. Animal is, : and then I want the value that was actually matched back on the left-hand side of my set. Everything you define in this atom, everything in this parentheses, has been assigned to a variable. They're numbered starting with 1. 1, 2, 3, 4, 5. Okay? Now, in Bash, how do we normally represent variables? $sign, right? The variable itself would be 1, but the value of the variable would be $1, right? This is actually how you reference back references in Apache, because Apache has the regular expression library built into it. This is how you reference back. Said, why would I do that? Backslash. I don't make the rules, I just complain about them. It's a backslash.
Starting on Facebook.
This, again, kind of a contrived example, but let's look at it. Let's do a test file here, vi tst.txt. We'll say my cat's name is Phil. My dog's name is also Phil. I have a weird family. Okay, so cat file, there it is.
I've met your family.
I'm going to pipe that through sed. I'm going to say, hey sed, search for cat or dog. You know I'm making this up on the fly, so it's probably not going to work, right?
The first time.
Place with
Got great
animal
troubleshooting
is...
skills.
There's no problem Sid can't make worse.
Jeez.
That's also a good
There's a good one.
Like that. Damn it! It didn't
Really?
work. Oh, it's because stupid bash. Because stupid bash. Bash.
You should get in the habit of putting this double.
I know.
There is nothing.
Cat
How'd
plus
that
dog.
say
Oh, that's very interesting.
No problem.
This
Sid can't make
a great example of said did exactly what I told it to do, but not what I meant it to do. Because look at my regex. Cat or dog, and then I had a quantifier on it. What is that? What does the plus mean?
0 or more.
Plus is 1 or more. 1 or more. So I didn't anchor the line, the rest of the line, right? So it replaced, it took that whole line. It took off it took off the my at the beginning, but it matched the rest of the line. I really just wanted cat and dog, right? So I shouldn't have put a quantifier on it, dummy. Oh, it still did it.
Oh.
All right, hold on. I got to put my brain in the right gear here. Cat or dog. Search for cat or dog. And the file looks like this. So it took off the my. Cat.
No, it's supplanted it all. It went in between.
Oh, it did.
It's got
You're-
animal is.
Oh, of
in
course
the
it
middle.
Animal is.
You're making my head
Cat.
because the way you're using your double quotes and that's going to really mess with things.
Why?
Why? Because the shell's going to parse that first, and it's going to break that as 2 separate strings inside of double quotes. It's going to leave a slash in between them outside of that. That could actually be passed really weird. Yeah, just do it that way.
I don't think this is going to change it, but okay.
Just try.
Same.
Okay.
So cat and dog is going to replace with animal is.
There you go, Adam.
Try tuning.
I probably should have come up with an example before I tried this, right?
Why wing it?
What if I just do?
You know, one motto.
Oh, it's not. That's not gonna. Yeah, that's gonna be the same.
Hey, you don't do this. Change change to /1, and I don't know if this is gonna work. Try changing it to /plus. I don't know if that'll work or not. But
No, it's working because if I take it out, I don't get the cat and the dog. See, I just took it out.
right. Change /1 to /plus instead.
Slash.
What's that do?
Wear it.
What's /plus mean?
Plus is
Put the
name.
plus.
No, it won't work in there. Okay.
No, the /1 is right.
Okay.
That's putting that back in there.
Both of them
You're gonna
might be
escape
dollar
this
sign
slide.
or dollar sign too. And
Yeah, that's why I wanted to say my
in fact,
animal.
normally dollar sign plus is class matched string.
All right, let me come up with. Let me do one more contrived example. Let's do this instead. So here's my file now. I'm gonna say, oops. search for, and I'm going to make an atom here, and I'm going to say class 1 through 5. And then I'm going to say number is back reference 1. And then I'm going to put a new line. Global. There. All right. Well, that one worked. I'm not sure why the other one didn't work. Here was the file. tst.txt 1, 2, 3, 4, 5. I catted it. I passed the sed, turned on the extended regular expressions. I said search for a number 1 through 5. Put it in an atom here. Notice the only reason I'm doing an atom here at all is to use the back reference. Because I'm not doing alteration, I'm not doing any quantifier, just solely so I can do back reference. And then I said number is, and I referenced the first atom. If I'd have had another parentheses here, it would have been /2, other one /3, /4, /5. And then throw a new line, and then end of the global. Number is 1, 2, 3, 4, 5. I don't know why that cat one didn't work. I'll have to think about that. Okay, again, kind of contrived. Now there is, that's it for the definition. Now let's go into some real-world examples, so hopefully all this actually gels in your head, because I know this is confusing. Let's look at a real-world example where I've used back references to that we actually need. Okay, the CareerLink website is old, and we made some pretty big modifications to it in the last couple years. So we changed the URL structure. But we got so many old links out there, we don't want to make all the old links 404. So we have a ton of rewrite rules that redirect old URLs to new URLs. We take advantage of the fact that Apache has built into it the extended regular expression library, so we can use that when we're doing these rewrite rules. Here's an example of one that this URL used to be valid. careerlink.com/9/9/0/5/jobs. Every company gets a 4-digit ID, and then this showed all their jobs. The new URL is this. This may not actually be right, but you get the point. I gotta convert this guy to this guy. I did that with a regex. Let's see what it looks like. Come on, mouse, work with me here. Yes, well, I do actually have a test environment for this. Believe it or not. Alright, bear with me a second, I'll fix this so you can actually see it. Bump that font up a little bit. It's better. Okay. This one I got my cursor. Yeah. This one I got my cursor on right here. So the Apache syntax is rewrite rule. And then here's the beginning of my regex. Anchor it with a caret. Here's an atom with the parentheses, right? A character range, 0 through 9. Could I have put bracket, bracket, colon, what is it, number? Is it number or digit? No, it's digit.
Yeah.
Bracket, bracket, colon, digit, colon, bracket, bracket. No. That's stupid.
Adam has no
I
opinion,
put
so.
0 through 9. So here's this, right? And then end by atom, then a slash. What does slash match? Itself. Not special. Another atom. Okay, 4 of those, right? Could I have done that better? Could I have done... Oh, I was thinking, why am I repeating these? Couldn't I have done brace 4? No, because I need the back references. And the back references are defined by the individual atoms. This is 1, 2, 3, 4. Apache, at least, for my sanity, uses $ signs to determine the back references. Here, please rewrite this URL to /employer/jobs, $1, 2, 3, 4. And it works. You see quite a few of those. Here's an alternation. I said alteration, that wouldn't have made sense at all. Ooh. Alternation. So profile, either end it or /end it. So no trailing slash or trailing slash. I don't know why I decided that one was important enough to have that on there, not the rest of them. I don't know. I didn't write all these rules. Here's an example of where I didn't need to use this final atom. So the old URL was number, PO, and then a 6-digit number, and I had to rewrite that. Oh, I did have to use it. Okay, I had to rewrite the job view 1, 2, 3, 4 slash, and then 5. So I did have a quantifier on this guy, but notice the entire thing is in parentheses. So this is the entire atom, not just the 0 through 9 part.
Must be all 6 characters.
With all exact 6 and only 6 characters. That's right. 6 and only 6. We have other interesting ones. They all pretty much follow that same pattern. These aren't that complicated. There's just a ton of them. Okay, here's one. Now this is actually 2 lines. Apache lets you chain these together. So in this case, if the request URI is not this, why do I have a slash in front of this dot?
Because you want to be literal period, not
Exactly. Because the dot is special. It matches any single character. I don't want it to match any single character. I want it to match itself. Therefore, you have to escape it with the backslash. Rewrite it to 3825. What does this mean? It's an atom dot plus. One or more of any character. So what this means is anything after this URL. And I have the parentheses around it because I'm using it here as a back reference. Dot plus.
Dot is 1 character, plus is 1 or more.
Remember, plus is not a regex by itself. It modifies the regex to its immediate left. 1 or more instances
The period has to match 1 character.
of dot.
And then the plus is it needs 1
No.
of the previous or more.
No, it modifies the meaning.
No, this is all, the plus, you can't say the plus does not have definition by itself. It only has definition with regards to the dot. The dot says any character, the plus says 1 or more of that character. You can't use it by itself,
Yeah,
it's
okay,
together.
right, I got you.
Okay? So this just takes anything I threw on the end here and calls it with this and sticks whatever I just threw. So if I say foo here, I'm going to get lavernecurling.com 9861 foo. Whatever I typed. To try to maintain these old URLs. That's everything else pretty much. Here's more alteration. This or this. So daily slash 0-9 and anything else. Or dynamic slash daily.php. This is probably the biggest place that I use regexes anymore. Chad probably. Hi, Chad. Chad probably uses them more than I do anymore. Here's an asterisk. Applied underscore underwriters. And then 0 or more instances of anything. So it'd be perfectly fine if it ended right there. That'd be 0. But I'll also accept anything else after that. Don't care. Now, in the bad old days, before I learned the right way, what would I have put here? I would have put that. Thinking that my file glob logic worked here. What does that mean?
1 or more S's.
1 or more, 0 or more
0 or more
S's
S's.
after applied underwriter.
Applied
Not what I
underwriter
wanted.
Or writers.
Right? It's so easy to do that. So easy to do that. Watch me not save that file. All right, one more. If I want to embarrass myself and look at this example.
Dun, dun, dun.
Use a dot.
This was a. So I'm not going to go into the whole long story behind this, but basically what this was trying to do was we had data that was stored in a file, in a delimited file, and there were like 38 different discrete fields in this file, all semicolon delimited, and each discrete field had a different type of data in it that we had to validate and make sure that the actual data that was in there was correct. Now, if you use a database, the database does this for you, right? It says, oh, this is a varchar, you're trying to store blob in there. No. When you have a text file, you can pretty much put whatever the heck you want in there. So you got to have an audit that makes sure the data is legit. This was my attempt at writing a regex that audited every single one of those discrete sections. And this is shell script, of course. In order to make this at least a little bit readable, I broke it up with the, if you've ever seen this in a shell script, if you put a slash as the last character on the line, it's escaping the new line character. So this is actually all one big long line. But God help me trying to maintain that. So, and the other cool thing about it, once you do that, is you can put comments after. So you can actually have comments on those lines. So some of these are pretty easy. So this is an atom with a pipe in the middle. So this is this or this. So exactly 7 occurrences of any digit, or exactly 6 occurrences of any digit with a dash at the beginning. So this could accept an integer up to a 7-digit number or a negative 6-digit number. This one is a little more complicated. Here's my arrange, any lowercase, any uppercase, any digit, or an underscore, 7 or 8 of them, then an underscore, then a digit, 5 or 6 of them, then an underscore, any lowercase, any uppercase, any number, anywhere from 2 to 8 of those, and then a .db. Dot not meaning any single character, dot meaning itself, because I escaped it. Or this other big long piece of code. Simple. Simple, right? Bang this out in an afternoon. Some of these are pretty obvious. Yes or no, lowercase or uppercase. Oh, come on, I had a good one. Where to go? Oh, this. What is this?
Four numbers.
Well, it's in first look all the way. It's an atom, right?
Yeah.
How many pipes we got? 1 pipe, 2 pipes. But look what's after this pipe. Nothing. So that means this could be
Empty.
this, or blank.
So it's got to be this format, or nothing.
Or empty. So forget anything past the pipe here. Look at this right here. What does this look like?
So it can be 4 digits.
And then a slash,
/ 2
Yeah.
digits,
and then a slash, and then
2 digits.
what is that?
Date.
It's a date. Somewhere in our infinite genius in creating this application, we decided along the lines that we were sick of slashes limiting our dates. Now we wanted dashes. So I had to accept both slashes or dashes in this situation. Now this isn't perfect. I mean, ideally, because of course 9999 would work for a year here. Probably not validated. So no, it's not perfect. Exactly 9 instances of a digit.
Social Security. Well, you weren't validating the actual input, you were validating the format that it was in.
That's right. After the fact. Well, I was validating the input after the fact, not live. I was running audits through this, finding out data that was bad, spitting out lines that didn't match for whatever reason. Okay. Here's a weird one: capital A to Z, lowercase a to Z, a space, an apostrophe, or a forward slash. I don't remember what that one was.
Take it out.
One or more instances of it. I wonder what that was.
Well,
Keeps curling running.
is that
No, this isn't been
Anybody
used
who's
since
middle name
06.
with forward slash.
What does that mean? Well, that's what I was thinking. It looks like a name, right? Well, it has a, I don't know. O'Brien, whatever.
Just add to the end of the file, always.
Just add it. So this, I mean, again, kind of a big example here, but yeah, regex stuff is pretty powerful. You can do some pretty funky stuff with it. And it's not, again, I maintain it's kind of like Linux itself. It's not complicated, but it's complex. There's a lot of moving parts. If you understand how all this works, I mean, now that you know this, you can see how you would go from here to here.
yeah.
And it's relatively straightforward. There's some weird crap for sure. This clearly bugs me to no end. I erased my caret example, but I hate the fact that caret means 2 different things where it is. I hate the fact that negation is not the bang where it is everywhere else. Okay? I hate the fact that we had to appropriate dot, star, and question mark because we thought we knew all those from our years of file-globbing, but we don't. So I think that's pretty useful. Apache, sed, awk, cut, grep. Visual Basic. Believe it. Has regular expression support.
BGP.
BGP? Really?
Yeah.
That's interesting. I did not know that. One last example before we call this good. When I was writing the O'Reilly book last year, and it always amazes me every time I do one of these. I always say I learned something new, right? I learned of an option to grep that I swear I never knew, and it has changed my life. It's pretty sad that an option to grep can change my life. That's the kind of life I lead. We've said all night that grep gives me back lines, right? So I was going to back lines. So you got to be careful to anchor your regexes if you want to match the entire line. Otherwise, it's going to default to what amounts to a substring match, and you're going to get you're just going to be too greedy, right? That's not 100% true. If you pass a certain option to grep, now I'll just look at the name. That is the -O option. Show only the matching part of a line that matches pattern. So it's not going to give you the whole line. It's only going to pull out the part that matches. I can't tell you how nice this is. Let's think of an example. I have a huge mbox file. Mbox is the text file format that a lot of mail servers store their data in. It is a weird, old, archaic format that you will kill yourself if you try to parse. Use one of the Perl libraries to do it or something. Let's say I want to pull all the email addresses out of an mbox file. Now, we can sit here and come up with a halfway decent regular expression that'll match an email address. It won't be perfect. Email addresses are notoriously hard to match. But it's going to give me every line, right? And then I've got to worry about, oh my God, okay, how do I just get the email address? You go through all these weird machinations with cut and TR and blah, blah. Nah, just pass -O to grep. It's a beautiful thing. So I have a simple one here that tries to do just that. Now, forget all this stuff at the beginning here. We want to get down to the nitty gritty, which is this guy here. Egrep. The egrep right here is what I'm looking for. Now this cuts over the line, but you'll get the point. Egrep -IO. -I is case insensitive, so I don't have to worry about case in my regex, which makes it a heck of a lot easier. O, only show me the part of the line that matches. And here, now I did not create this. I totally stole this from the site regular-expressions.info, which is a great site. It talks all about regular expressions. This is his best try at matching email addresses. This is already out of date, thanks to the geniuses at ICANN, that now if you have enough money, let you buy whatever top-level domain you want. Not exactly sure how I'm going to create a regex. I don't understand.
Not really.
I don't have $275,000 to buy it, though, Aaron. And what, $20,000 a year to renew it? Isn't something like that? Jump right on that. Okay, so.
Why isn't there one already?
Well, I'm already missing some from here. I don't have .xxx in here. That's a valid TLD now. I don't have .coop in here.
I'm hoping you're not getting email from
That's a
them.
valid TLD. I'm just saying, that just got ratified a couple months ago, didn't it?
Which one is 127.0.0.1? That's the one.
As a
That's the
TLD.
one you want.
There you go. I want .localhost.
But you're also missing another country.
Actually, I really don't. What?
You're actually missing another country like .uk.
Oh, no, that's right here. We'll get there.
Oh,
It's right there.
Ooh.
all right.
Okay, so to begin, we have no atoms here, right? Well, okay, one, but we're not there yet. At the beginning, we just have a character range, bracket, bracket. A to Z, remember I don't have to say lowercase here because grep's handling that for me with the I. So A to Z, 0 through 9, or a dot. Dot inside a character range doesn't have to be escaped. Definitions change inside character ranges. They supersede the regular expression ones for caret and for dot. Don't have to escape that. In fact, I put a slash in there, it'll assume slash,
Yeah.
Yeah.
which is invalid for an email address. Underscore. Did you know you can have % sign in your email address? Or a plus sign?
Yep.
I'm sure Tom does. And dashes. Okay, so any of those, how many of them?
Infinity.
One or more. It's got to be at least one. Can't be zero.
Yeah, it has to
right?
be something.
Because then I got an @ sign. The magical @ sign matches itself. Then, the plus, one or more instances of, this is the domain name right here. This is the TLD, the top level domain. This is the domain name right here. Now you may say, okay, what about the host name? What about if my email is bob@mail.unomaha.edu?
Still works.
It still works because
The dots in
I
there.
have a dot right there, exactly.
And a dash.
Any letter, any number, a dot or a dash. One or more instances of these. Could be 50. Whatever. And then here's my one atom. So here's my parentheses. Here's the TLD. This or this or this or this or this. Here's the country code TLDs. A through Z, exactly 2 of them. Or, com, or org, or net, or e, or blah, blah, blah. Dot museum. Has anybody actually been to a dot museum site? That is a valid TLD. According
Never
to
heard.
Wikipedia. Wikipedia never knows.
I actually saw one. It was the museum.museum, I think is what.
Museum.museum. That's just cheating.
Well, no, it's their registration site.
Oh, okay. That's pretty good. Okay. So the idea of this was to grep out, and the -O only show me the email address, and then the little TR here. TR also handles regular expressions. TR, convert all the characters from uppercase to lowercase, sort it unique. So if I actually run this, let's see. I got some. Here, I'll do a sample one because if I run it against a normal inbox file, it takes like forever.
What about our instinct?
Adam@org. This is Adam@adamhaeder.com. Mine is Adam@careerlink.com. And then there's Bob@AOL.
Wow. I had
So-
to throw the AOL at you, man.
There's my file. There's my file.
Last comment, tip the balance.
You pushed me over the edge. Oh, hold on. I gotta make sure that actually is accepting it. Oh, file 1, yeah. Oh, I'm sorry, it's grepping for from. It only wants to see from addresses. Forgot that script did that. Well, let's cheat and we'll just pull the regex out.
Acquire.
So we'll say cat my test file, and we'll pipe that to. And of course, Bash is going to barf at me because it hates me. Bear with me, we're almost done. Name, arrow. You ever seen a .arrow site for airports? Believe it. No. Only pulls out the email address, prints them. Didn't get Bob at AOL. Didn't get all the extra garbage I put in there. Just got the email addresses.
How about that?
Pretty useful.
What about the Huffington Post?
That's it. That's regular expressions in a very large nutshell.
Thank you, Adam.
It's cool stuff, man. I tell you, you can do some wicked, weird things with this. You can do some magic foo with this. It really is. Especially on the Apache side, man. The rewrite rolls in Apache here. That's some magic right there. But it's fun. I do like this. It obviously annoys the crap out of me sometimes, but it's fun. I do like doing this stuff. It's good times. It is. Okay. What time is it? Oh, it's 8 o'clock. Look at that. Perfect timing. 8 o'clock. All right. That was it for the August meeting. We have September meeting coming up. I need speakers and I need topics. What do you talk about?
Like how Slackware has let you down.
Well, there's that.
Dependency bitch slapped.
It just got to the point where I had reached my
No more, huh?
episode
You know,
of spending 4 hours
Debbie will welcome
plowing
you.
through dependencies.
How about Unity? Anybody want to
Yes,
talk
but
about?
it'll hold my head under
Anybody want to talk
water
about
while it's
Unity?
welcoming me.
No, nobody wants to talk about Unity.
Goodbye,
I have
everybody.
Unity on my laptop. It's not.
We're calling this an end.